SwayamPrabha. Digital India. Educated India.
Hello and welcome to this Manufacturing Systems Technology Part 2, Module 17 and 18. So, you have the both the cases recorded here of the control chart. So, we now actually start plotting these charts. You can see that the X double bar line particularly is falling around, as I had illustrated earlier, the mean of means was 0.8758. So, this is how the X double bar has been recorded, and you have the UCL, which is based on X double bar plus A2 R dash, where I think A2 had been illustrated as 1, okay, for a subgroup size of 5, and similarly the LCX has also been recorded as X double bar minus A2 R bar. I think I have described this while doing the recording. So, you have a recording of the observations in the previous form. So, you have a LCL and the UCL constructed for the X double bar chart, and similarly if you look at this particular portion, you can see the UCL and the LCL. So, there does not exist an LCL because the subgroup size is less than 6, and so therefore, the limit here D3 becomes equal to 0, and D4 is basically the range in this case, which is actually 2.11. I think I had suggested this, and this can come directly from the Shewhart chart table, which I will share with you later on when we finish this particular module. But therefore, you can actually calculate the R bar and the UCL in this particular zone, and now all you need to do is to actually independently record the different X bar values. These open dots, for example, are those X bar values, and the moment it goes beyond control, you will see one value going out of this particular UCL or LCL. So, there is a very good real time indication of the process happening and how to control it. So, this for example is the the later on case when we talked about that what happens after the second control chart with a lesser degree of accuracy, and also let us say after the correction factor which has been incorporated, because earlier the samples were all heated and the dimensions were slightly changed because of that heating. So, there are some variations, as you can see, from case 1 to case 2 because of that. And so, similarly from again the range chart also, they are quite variable in terms of their mean or the UCLs or the LCLs and how far they are away from the mean, and obviously a tighter control or a better control can be reflected in a probably second case here, because it is accommodating for that factor of post cooling recording of the milling width, slot width into question. So, I think this is sort of giving you an idea of how the control charts can be plotted. Now, the other issues are about some of the preliminary conclusions that you can draw from this chart. So, the first conclusion that you can draw is either whether the process is in control or is out of control. So, you either have an indication of control process or a lack of control in the process. So, lack of control obviously would be indicated by points falling outside the control limits on either side of the control charts, and when the points fall outside the control limits, we say that the process is out of control. This is equivalent to saying that assignable causes of variations are present and this is not a constant cause system. In contrast, if none of the points fall outside the control limits, then no assignable causes are present. So, that is very good interpretation. Also, you can interpret for all the processes in control with the evidence from the control chart that a process is in control. We are in a sort of a position to judge what is necessary to permit the manufacture of the product that meets the specifications of the quality characteristic charted. So, you can have, based on a control process, an analysis of comparison between the specifications and the process control, so that you can determine whether your process is capable of producing the specifications. So, here the control chart would give you data about the centering of the process and the dispersion of the process, and you can see whether the process is out by 2 sigma or 3 sigma and all those different issues by aligning the specification limits given in the design with respect to the process limits which happen by the control chart plotting. So, this for example is a sort of kind of possible relationships which would exist in sort of control to upper and lower specification limits of a process. They are showing 5 different processes here. For example, you can see A, B, C, D, E. These are different processes, and in some cases it is going in a manner, or it is placed in a manner so that part of it is going above the upper specification limit as given to the design details. Okay, and so therefore we can say that these processes are out of control, and there may be some rejections because of that. However, what is good in this process is that the dispersion and the mean are placed in a manner so that they can be with a little bit of process control well within the upper and lower specification limits. Okay, because this you can see the overall sort of process spread, if the mean were to be centered around the specification mean, that would really cause almost 100% acceptance, because there are hardly any values which are falling outside the upper and lower specification limits. In the second case here, for example, this is case 2, you do not find that to happen. You find out that this is a very well balanced process where if you were exactly at the center of the specifications, that would be the only case where you have 100% acceptance. Okay. And in fact, this process is even one step ahead, where even if there is, let us say, a centering, there is always a tendency of some rejects to be produced. So, these kind of linkages between the specification limits in the design specifications as well as the process control which has been listed here would really enable you to analyze about the process capability of a machine. So, if the process is really capable of producing a specification, you typically have the case 1 type of condition, and case 2 and case 3 would really not emerge. And in case you have a case 2, case 3, then you have to either consider revising the specification limits, which is really related to the change of the design specs, or alternately you will have to do something to enable your machinery so that your process control can become tighter and it can be over the mean and the spread can be less. So, these are some of the interpretations that you can really have from all the control chart experiments that you have done. There are some more interpretations which we will detail later on before we go to the attribute control chart, which probably do in the next lecture. Thank you so much.